Guys, how's everybody doing? Good? I just got 4 fidget spinners all at the same time, and now I'm comparing them. I don't know, does anybody have this one? Check this out. It's like mystical. It's totally amazing. All right, sorry. This is not fidget spinner reviews. This is Exploit Kit Cornucopia, although it may change into it. All right, so my name is Brad Antonowitz. I work for Cisco Umbrella, and I do security research there. We do, our goal at Cisco Umbrella in our group is to find stuff to block, and so that's kind of what we're going to be talking about today.
Hi guys, I'm Brad's coffee trainer, or coffee fetcher in training. No, I'm Matt Foley. I'm an intern at Cisco Umbrella, and I'm also a CS student at NYU's Tandon School of Engineering.
This is basically all of Matt's work. So just keep that in mind as we go through all this. All right, so today what we're going to do, like I mentioned, in our group we do a lot of research, and we spend a lot of time detecting things all over sort of the spectrum. And we decided, we sort of were doing all of this exploit kit research, and we found some really great ways to identify exploit kits and block them. And we also found all of these kind of other things that by themselves weren't amazing talks, they were too short of items to go over in a single talk. So what we did was we were like, you know what? We're just going to combine them, and you guys are going to get basically 4 talks in one session. So you're going to see 4 different ways to detect exploit kits and all types of different things that we've put together. So basically, this is the best bang for your buck you're going to get at Black Hat. So we're going to talk all about a little bit of background. We're going to start off with some background. So if you don't know a ton about exploit kits, we'll bring you up to speed really quick. And then we're going to give some detail into our crawler. We'll tell about ways that you can amplify conviction. So once you get one thing to block, once you find one part of an exploit kit, how you can sort of amplify that and find a lot more. And then we're going to look at this kind of interesting thing that we found. We found a vulnerability actually in some of this exploit kit stuff. And so we'll show you that vulnerability and talk about it. And then the last part is we're going to bring it all together with talking about a way that you can look at and easily obtain the malware that's often distributed via exploit kits and just general sort of phishing campaigns. All right, so first and foremost, I want to talk about the background. This is my favorite exploit kit site ever. I'm from New Jersey, right outside of New York, and this is a legit website. This is nycrunningmama.com. The person who runs it is this woman named Michelle. She lives in New York. It's like, I feel like I could run into her on the subway at any particular day or time. She loves, she really likes to run. So she goes out and she does all this running. She loves her kids. She seems like a good mom. She takes pictures, posts them all up on her WordPress site, and kind of shows them off. And people go to it. Like Michelle has, I think, like 16,000 followers. Like she's kind of a big deal. I mean, at least compared to me, I have like 5, right? So she's definitely some, pretty awesome. The thing about Michelle is that she's not like a WordPress admin. She doesn't know about computers and like hacking and all that stuff. She knows about running and being a good mom, right? And so something sort of unfortunate happens when you go to Michelle's website, depending on what browser you use. So you get 2 different experiences. On the left-hand side, when you go to Michelle's website using Chrome, you render everything fine. But on the right-hand side, something different happens, right? There's something a little sort of strange that's happening there, and that's, is that, I guess, left-hand side? Sorry. You know which one is wrong? So the one that's wrong is the one that has this pop-up that happens. Now, the messed up thing about this pop-up is this is no JavaScript pop-up. This is not just some like alert or something like that. This pop-up is occurring outside of the context of the browser. When you visit Michelle's website, something happens where executable is running locally on your system and crashes, right? This is not what NYC Running Mama is about. So it's sort of strange. So if you look a level deeper, you see sort of something more into that story. So if you look at the Internet Explorer side, you'll see that there's a couple of extra added lines in there. And those lines aren't also present in Chrome. And if you look at those specific lines, they actually match a very specific and distinct pattern in the exploit kit community. It matches the sudo dark leech campaign using the rig exploit kit. And the way that we know that is by the actual sort of characters that are there, the length of those, there's sort of 6 lines, there's some random characters, there's an iframe, some more random characters. That whole pattern is a way that we can identify sudo dark leech, and we can also identify rig through the URI in the iframe source based on that. And so we can really quickly identify that. And so to help you understand, Michelle's website is actually now participating in an exploit kit. She doesn't even know this is happening, right? But her WordPress site got compromised, and now she's now serving up an exploit kit. So exploit kits over the years, they're nothing like brand new. They've sort of evolved over the years. Some of them really great. I don't know if you saw the one with the gun and the weird white powder substance. You log into a cell phone. Like, they're really embracing the whole criminal ecosystem at that point. And so with these exploit kits, what they do is they essentially are selling you the ability to execute code on your victim system, right? They're a website that when someone visits that website, they get sort of targeted with an exploit, and that exploit then delivers some payload that the criminal has purchased and is paying for as part of this whole ecosystem. And the payload is usually, as far as the exploit goes, the exploit's goal is to execute a one-liner. So this is kind of what the one-liner would look like. What it's basically doing is it's writing out onto disk a VB script, and it's then executing that VB script. The VB script fetches a DLL from the internet and then executes the DLL. So super simple, but at the end of the day, it's really effective because it's taking advantage of a vulnerability in that browser. Usually this is, because it's part of this whole criminal ecosystem, usually it's meant to distribute like ransomware or banking Trojan, something like that, so that a criminal can make money off of it, right? Now, Michelle's website in the exploit kit world is called a compromised site, right? Her website got compromised, and now it's redirecting. The compromised site acts as a proxy between the victim and this back-end exploit kit ecosystem. There's an exploit kit server that's there, and the compromised site actually makes requests to the server to pull in that iframe content. Now, there's another way that's really popular for exploit kit authors to use, and that's called malvertising. That's the bottom part of the slide here. This sort of second way works with ad networks. So ad network subscribers, people who sign up to make money off of selling the space of their website, will opt into an ad network. And what the attackers will do, the exploit kit authors will do, is they'll sign up as a publisher to this network. And so they sign up. They have another system that will be the ad, but is basically just the iframe itself. And whoever is a subscriber to that ad network then will be publishing out this exploit kit, and the same thing happens. In this case, the attacker's machine operates as that proxy between the back-end server and the victim, and they infect the victim with whatever they're going to infect. Now, there's another sort of area about this, too. Once you get that iframe and actually sort of render it, you're also going to get an exploit. But before that, what needs to happen is that there's a whole bunch of filtering that happens. So imagine you're an exploit kit author, and you're trying to sort of attack someone, but you're also trying to protect yourself against researchers and things like that. Well, what you do is you filter heavily the people who are coming to your system. right? You don't want to send an exploit to a researcher. You also don't want to send the wrong exploit to the wrong browser or version because it's not going to land and it's not going to be successful. So there's a big thing that happens in all of this is that exploit kit authors use a heavy level of filtering to figure out who they're actually going to target at this stage. When someone lands on one of these ads or these compromised sites, they're trying to figure out who they're going to target. So this is Kitaro. It's a TDS, or a traffic distribution system, and it's commonly used in ad networks and advertising. And what we're seeing is that some exploit kit authors are actually using this itself as part of that filtering function. So if you start to see, you'll notice that there's just a crazy level of filtering that you can do with this. You can pick your users based on geographic region. You can base, do you want a mobile or non-mobile device? What operating system down to the version, and browser down to the version. You can pick certain plugins and extensions. You can literally drag and drop what detail you want to target. And when you do that, you set up what's called a flow. And these flows say, you know, this user that matches this level of filtering gets served up this exploit. This user who's maybe a mobile user doesn't get served any exploit because we don't have a mobile exploit. And so they use this really heavy level of filtering through all of this. And one of the things that we were able to do, which was kind of fun, was we were actually able to get access to the web roots of a lot of these compromised websites. And we actually started to look at them and see, all right, you know, looking at these web roots, what information can we get? And so what you're seeing on the screen, we started out with using something called Hashed, which is just a free known good service. You can give it a list of directories and it'll tell you, or a list of files, it'll tell you which files are known goods. So this is a WordPress installation. So I'm just going to quickly remove out all of the known good WordPress sites. And I'm left with a core file as part of WordPress, which is the navmenu.php. Now, sudo darkleech is also notorious for using this navmenu.php file to store their back-end code. Okay? So what they do is they compromise the website, they manually modify navmenu.php to include their code. This code is the code that fetches that iframe information and renders it in the compromised website. But it does a bunch of other things. So it's kind of interesting to see. So first, they don't serve the iframe to every single page. They don't want to embed the iframe into images, right? They don't want to embed the iframe into just any page that, that gets rendered. They pick only the specific ones. The other thing is that built into this injected code is filters for Google's IP addresses. So they're actually put in place whitelists so that if it's a Google, certain Google search engine, like crawlers, IP addresses, won't serve the exploit kit or won't fetch that out. And then they also, the other weird thing about this, I don't know if you guys have noticed this, but there's comments in this code, which is kind of weird, right? Because you think like, you know, commented code suggests like, you know, something under development, right? This code is found on a compromised site. So that means that maybe they're either deploying this commented out code to all of their systems, or they're manually going into this compromised website and testing it live in production, testing this backdoored code, which is kind of interesting. So the other thing that they do is, you'll see in that, and we'll dive into that in a little bit, is that they're also have a string, a base64 encoded string, that is actually what that call is to the rig server, and we'll look at that in just a minute. All right, so the other part now is actually getting the exploit. So first they get the iframe content, and now when you render that iframe, the victim renders that iframe, now they need to actually be hit with the exploit. So this is sort of hard for us to see because this is happening on systems that we don't control and we don't have good visibility into. But from what we can tell, it looks like there's another system called a VDS, or a virtual dedicated server, that actually holds the exploits. And that domain that actually that was in the iframe fetches back from this virtual dedicated server to pull the exploit and then render it. When you actually get the exploit is really an exploit bundle. You get 3 different heavily obfuscated exploits. It loads all 3 of them. At least for this particular case, it'll launch all 3 exploits against your browser and your plugins. And the exploits themselves aren't anything amazing. So, a few years back, Angler Exploit Kit was the most popular. Those guys really innovated well. They were doing lots of really cool, interesting things. Ever since then, we haven't seen a lot of really strong innovation in the exploit kits. What they do, and by innovation what I mean is writing their own exploits or coming up with unpublished exploits or anything like that. So what they do is they're using old, a security researcher finds an exploit, they write up a proof of concept, publish it to a blog, and then within a week, an exploit kit author takes that, sort of weaponizes it, and loads it into an exploit kit and serves whoever they're buying. The funny thing is that you can sort of see some of the lack of innovation in a way by the way that they're dealing with these exploits. So sometimes when they have a browser that they can't actually exploit, they'll do sort of lame things in the exploit world, right? They show these sort of fake font pop-ups, which try to convince you to click a link and download something. Like, to me, this is super lame. Like, these guys are exploit kit authors, right? Like, they should be dealing with memory corruption vulnerabilities, right? Bypassing exploit mitigations, doing some hardcore stuff, and they're resulting to this fake font download. This just, to me, like, is an uppercut Mortal Kombat finisher. Like, they're really not doing amazing. So there's obviously a ton of stuff going on with exploit kits, but the weird thing about all of this, there's so much activity happening with exploit kits that I thought it was weird that there wasn't like a website to track all of these. So what I did was I reached out to some of the popular exploit kit researchers and talked to them a bit and asked them if they would contribute and built a website called ektracker.com. And so now you all can go to ektracker.com and for free have a list of brand new exploit kits that are detected minute by minute by exploit kit researchers. The other cool thing about that is now we have a public data set of exploit kit stuff that we can play with and look at. So this is a visualization I did with the data off of ektracker.com, and we did a really simple visualization. We looked at the relationships for IPs to ASNs. So which, from all of these different IPs that were known exploit kits, what ASNs do they map to? And you can see one really, look at that. That's a crazy mapping, all of those IPs to just that single ASN. So that was really sort of an interesting piece of information. And we did the same thing to domains and registrants. So we were able to see, how many domains and were there offending registrants. And you can see at the center there, we have a single registrant associated with a whole huge cluster of different domains that are associated. So that's a really good use case for ektracker, just getting it all out there. So hopefully you guys will use it and find value in it. Cool. All right, Matt, you're it.
All right, so how do we detect exploit kits? The first method we'll look at is probably the most common approach, and it's the approach that we took first, and that's to build a scraper. We focused on identifying the exploit kit landers because we already had a good corpus of known compromised sites sort of compiled. And we actually had 2 versions of our scraper, and with those 2 separate proxy networks. So we'll break each of those down individually. So the first version of our scraper was built using VirtualBox, and Vagrant was used for sort of starting and stopping the virtual machines as well as snapshot management. The host OS was also responsible for hosting the multiprocessing queue that the workers fed from. So here's just a brief look at one of the worker processes. So you'll notice that we're making 2 requests per compromised site, one with Internet Explorer through Selenium and one with Python requests. And this lets us take a diff of the rendered DOM versus the page source that was given to us. So this allows us to identify any iframes, embeds, params, or other includes that occurred post JavaScript execution. And this diff gives us a candidate list, but we still need to weed out some false positives. So we run it through a couple of filters. We're really lucky in the sense that we have access to a popularity score in our product. So it works pretty similar to Google's popular PageRank algorithm. Another one of the interesting things that we can look at for filtering is the DNS query volume that these domains receive. So for something like google.com, you'll see a huge amount of volume over a large period of time, and it's very periodic in its graph. With something like an exploit kit lander, you'll see a dramatic spike preceded typically by either 0 or no queries before it. So that's how the first version of the scraper worked, but we're still missing a key detail, which is how we actually got around the IP filtering that they do. Typically, they have some filter in place to make sure that you're coming from a non-corporate IP, or to make sure they haven't served you an exploit within the last 24 hours. And to do this, we built out a proxy network. The first version of the proxy network looked a little something like this. Yeah, there you go. We just scraped a bunch of public proxy lists. And this actually worked surprisingly well for a couple months at least, until every single one of the proxy lists that we were using got blacklisted. So we started working on version 2. And by this point, the most advanced exploit kit, Angler, had shut down. And the ones that had taken its place really weren't doing the same level of browser scrutinization that Angler had been doing. So this allowed us to make a much lighter version of our scraper. So we didn't have to use virtual machines anymore, and no PyShark for saving the samples, and no diffing. So now we just have a browser component made entirely using Python requests, and we fetch the page, pass the response to a detector, which just does some very basic signature matching over the response to identify any exploit kit landers and take a guess at its campaign. And then these lander candidates are then queried and passed to a decoder module. So the decoder module just takes the response from these exploit kit landers and does its best to it runs it through a JavaScript parser first, and then does its best to take a guess at the exploit kit that it's looking at. And from there, it'll try to extract any, for example, flash exploits, executables, or any other artifacts. The second version of our proxy network, we actually built out ourselves. We host it across a bunch of hourly VPS providers using Squid Proxy. And this gives us a lot of flexibility in the choice of region for our exit IP. So if certain exploit kits are only targeting certain regions, we can choose to be coming from there. And it also gives us rotating IPs every hour or 2 hours. And so naturally, the question becomes, well, what do you scrape? So some great resources are on the left-hand side. Those are just researcher blogs and ektracker.com. Twitter is also a great resource for intelligence sharing. So, for example, if you were to sit on the RigEK hashtag, there's just a ton of information that you can harvest from there, from other researchers publishing open source intelligence. And the last idea actually comes from a Twitter researcher, Nalsec. Typically, when we think of the Alexa 1 million, we think of these sites as sort of reputable or sites that we can trust. But he actually found that a lot of the sites in the Alexa 1 million are compromised and were serving exploit kits at one point. So the Alexa 1 million, or we also have the Cisco Umbrella 1 million. All right, great. So we now have a bunch of exploit kit landers, but Brad and I wanted to do more with this. We wanted to amplify the convictions that we were getting with our scraper. So we built out this system called Hitlist to do that. And so when a customer using our product visits a site that's blocked, instead of returning the IP for that site, we actually return the IP for one of our block page landers. And so every time someone hits one of the block page landers, we try to store the session information in our logs. And that way, when someone visits one of the exploit kit landers that we've identified, we're able to look at the referrer information, which could potentially be a compromised site. All right. So the block page logs are stored in S3 buckets. And currently we have Hitlist running using a custom stream processing framework that we've created called Avalanche. But we also feel that it could be the perfect use case for a serverless architecture, so something like AWS's Lambda. So we could push the results from the scraper into another S3 bucket. and feed these along with the block page logs into a Lambda function to produce compromised site candidates. These the Lambda function could be something super simple, and we could just check to see if the host is in our EKLander list. This creates this really nice ecosystem where hitlist finds new compromised sites, and the scraper can confirm the hitlist detections as well as provide new exploit kit landers for hitlist to work with. And so it's 2017. We have to justify our work through data visualization. So we built this graph over the first less than a month of hitlist data. So you can really see the amplification that we get in this graph. You'll see a bunch of clusters, and at the center of these clusters are the exploit kit landers, and all of the nodes connecting to the center are compromised sites that hitlist found. So in some cases, you'll even see like there are 20 plus compromised sites connecting to a single exploit kit lander. And these exploit kit campaigns are operating at a scale of thousands or tens of thousands of compromised sites, as you can see just from how large the graph is over just 1 month of data.
All right, cool. I'm back in, tagged. All right, let's do this. Okay, so the next sort of thing that we wanted to talk about was something that's kind of interesting. It's the actual backdoor or the actual code that they inject. So again, back on Michelle's website, when we were looking at that navmenu.php, there was that code that's there. And in that code, it did fetch the exploit kit, that iframe, and render it to the victim. But it actually did a little bit of other things as well. So what's kind of interesting about it is if you start to think about, Matt just said that there's potentially tens of thousands of domains that these campaigns are managing. Like when you start to think about how they have to deal with it, they're facing like an orchestration problem, right? Like they have so many compromised sites that they have to figure out how to orchestrate all these at once. And so what they do is they actually have a backdoor in place. They actually have a piece of code in that snip that I showed you up front that allows them to access these compromised sites using a specific method. So this is a pretty well-known, the backdoor itself is pretty well-known. It uses a preg replace function. This is a function that's available within PHP. And all it is a simple sort of line substitution. So you give it a string, you have a regex, and it'll find that string and replace it with something else. But because we're talking about PHP, and PHP is, I don't know, bonkers sometimes, they also have this great thing that you could add on to your regex, and it's a trailing E. And what that trailing E does means is that it will treat the resulting string after that match and pass it through eval. So if you pass it PHP code, it will execute that PHP code. If you pitch a string of PHP code, it would execute that string as it were PHP. So this is a really common backdoor that people use in sort of the PHP world. And they usually do it by setting cookies. So normally you set 3 cookies, and what they'll do is they'll embed this backdoor somewhere in the site, and then if you have the right cookies set up to sort of recreate this preg replace backdoor, you'll be able to get code execution on that compromised site if you have the right cookie set up. Now, one of the critical flaws that the sudo dark leech campaign made when they're doing this is that they didn't use cookies. They used post data. So that might not be obvious why that's a problem, but hopefully I'll explain it in just a second. So what they did to secure all of this is that they actually set this really long string. It's a password. You see it in the bottom highlighted in yellow. And that really long string is the security for this backdoor, right? Can anybody take a guess at what that string is? It's no, I wish. It is a password. It's not the word password. But I think what you're implying there is that this is a hash. And it is, right? It's a hash. We don't know for sure it's a hash, but it's obvious. So we started to look. I was like, all right, well, what the heck is this hash? Like, what is this thing, man? Like, what is it? Is it password? What it'll be? So I Googled it. Like, I mean, you know, how else do you figure things out? And so I Googled it, and I started to see all these results for this integer value, this 102, I think like 102, 117. I've got to look at the slide. And I started to realize, like, wait, this is a hash value of the string of an integer. It's this number. It's a hashed number. Like, this is weird. What's going on here? And so I started to look at it and confirm it. And in fact, it was. And so I started to look at it even more and say, what is this value? And so when you start to dig into these exploit kits, you'll find this interesting function. I mentioned at the start that there was this long string embedded in that code of PHP. Now that string is base 64 encoded. And they do some other sort of like, they move around the numbers of IP addresses to make it difficult. I don't know. It's all, you see the code, so you just know how to fix it, you know? So they do all that. They change all this stuff around. But when you unencrypt, quotes, this base 64 encoded string, what you see is that same number, that same, you know, whatever it is, 120, 117, 102, 117, one of the two. So you see that same number pop up in that URL. And so because we had access to a bunch of these different web roots of compromised servers, we started to look at the other URLs. And sure enough, embedded in that decrypted URL for all of those compromised websites, they had this same sort of number that was there. And what we think it is, based on just sort of understanding RIG and sort of public information, we think that that's the user ID of the user subscribed to RIG exploit kit. So, you know, you purchase subscription access to RIG. RIG, you know, probably gives you a user ID, right? And so that's what you use in URL to get that iframe or get that content back. So we started to get all of these different user IDs, and it turned out that these user IDs were really, really sort of easy to use and to turn into full backdoor access onto these systems. Once you knew the user ID, you essentially knew the password just by MD5ing it, right? So if you want to access the backdoor, this is your remote command, right? You just set up the variables correctly, and you just sort of set one of the keys to be this MD5 value, and you're good. Now, this still requires you to know this user ID, and that kind of sucks. Like, who's going to know that user ID? But there's something really great about this user ID. It's an integer value. Like, it's, you know, what, it's an 8-digit integer? Like, come on, man. And there's also something else, right? Because remember at front, I said normally they would be using these in cookies. Right? At first, they would be using these values as cookie values, but here they're post data values. And there's one really important attribute about post data is that you can support lots of it. You can send a lot of post data to a server. You want to upload a file, you send it as post data, right? You want to do anything else, you just sort of send it as post data. So hopefully you could see where I'm going with this. So a lot of times these compromised sites, they are running either Nginx or Apache. Nginx default post data size is 1 meg, which is a heck of a lot of post data, if you think about it. And Apache is just out of control. They're just like, you know, YOLO, whatever you want to send, which is wonderful. So what you could do here is you could brute force this value, right? Like, a brute forcer is simple. At this point, all you have to do is just, since we had a bunch of compromised sites, we know roughly the range of integer values that this is all going to be. And so to write a brute forcer, you're just basically writing a for loop in Python, right? And you're just MDifying that value over and over again. So the initial backdoor access would be sort of something like this, where you would just send that single password as the value. But once we actually want to brute force it, we just send it a larger amount of post data, and we just brute force hundreds of passwords at once. And if any one of those 100 passwords actually lands and is actually correct, then our code gets executed. And we could batch this into sizes that are appropriate to the web server so that we can brute force it really efficiently and really quickly. And so you could totally do that. And if you do that, what do you get? So what's kind of fun about this is that now you have the ability to act as the proxy to these networks, right? So normally what would happen is you'd go to Michelle's website. Michelle's website would pull your user agent, pull your IP address, and then pass it on to the rig backend server, which would then do a bunch of filtering to say, this IP address has hit me a bunch of times. Let me not serve the exploit. But here, now we can spoof everything, because now we're Michelle's site. We're that compromised website, and we're controlling what data rig sees. So we can only use user agents that we know are really good, or we can test lots of different user agents. We can set any IP address that we want, right? Because we're controlling it. And we can just regularly set up that we're constantly requesting over and over again new gates, because these gates are revolving. They're rotating on a regular basis. So now we can just sort of use this as a proxy and just request more and more gates and find more things to, more bad of this network and uncover more of that infrastructure. So we found out that the backend server that's hosting this is almost always, in the cases that we saw, were on Hetzner. Now, if you've done a lot of this research, Hetzner is a good, generally a good service. They do really, really good stuff. But it seems like, for whatever reason, these actors love Hetzner more than anything. And so every case where the rig server, because we're also uncovering the rig server IP in this whole process, so we actually know where that server is that's controlled by not the criminal, the actual attacker who's offering the exploit kit. And so we know it's almost always on Hetzner, so that's amazing. That was a good piece of information. And we were able to get a lot more of these gates. So that's sort of an interesting fun little backdoor that exists in those systems. And that's still there as of today. So, I don't know who to report the bug to. Is there a responsible disclosure? I don't know. So the other thing is, we were also thinking about ways, like we were like, all right, we were looking at all this exploit kit stuff, but what's really exploit kit, like what are they really doing? They're sending you ransomware, they're sending you banking trojans, that sort of stuff. So, let's try to focus on that end game of these exploit kits as well and try to understand these samples and pull them together. So we were thinking about it, we were like, all right, well, how are we going to get lots and lots of samples? And we were like, well, one of the things that we could do is we can set up sort of email honeypots. So we started to go down this route. I'm sure many of you have gone down this route before. You want to sign up, you maybe register a Gmail account and sign up for lots of crap. But it turns out like Gmail is a good service. So they are looking at your attachments. They're looking for phishing campaigns, and they're actively blocking them or publishing them to your spam folder. And we don't want that. We want the crap, right? Like we want the bad stuff at the end of the day. So I started to think about it like, I could set up my own mail server, but that kind of sucks. Like I don't want to set up my own mail server. Like, I mean, it's not hard, but it's just like, I don't feel like it's going to last forever. It's not great. And then I still have to sign up for all this crap. Like I got to go and sign up for all this, threat reports and, all the other stuff that gets you the nasty information. And so what I started thinking was like, well, wait a second. I always use, when I want to sign up for nasty stuff, what I use is a disposable mailbox. I go to mailinator.com. And when I want to, sign up for something that's probably suspicious and may result in compromise, I'll just use Mailinator. It's a disposable mailbox, a single one-use mailbox. The trick about it is that anybody could read your mail, but who cares because it's just this one-use mailbox. And so I was like, all right, well, let me see. What if I used Mailinator as my email honeypot, right? Will it work? So I tried it out. I was like, all right, cool, let's build a quick system. We sort of prototyped a quick system. We called it Mail Runner. It basically pulls data from Mailinator, feeds it into ThreatGrid. We're Cisco, we get ThreatGrid for free. And we pass it through a classification engine for stuff. And if you think about it, if an email has an attachment, and that attachment is reaching out to the internet, that's probably bad, like most likely bad. So we do some basic filtering on the results of the ThreatGrid results. And sure enough, we were happy to see that we actually found stuff. There was actually one day around this time last year where 1/3 of all of the email that we saw in these mailboxes was actually locky. It was crazy. We found Odin, we found all this other stuff. So we were like, great, this is awesome. We're finding like good malware. This is like a source of it. But the problem is we're using Mailinator, and Mailinator costs money. And that's like we actually paid for the API, just make it life easier. So we said, you know what, forget it, man. I'm just going to roll my own. So we created lacedmail.com, and the whole purpose of this is for you guys to do the same thing. So I basically don't want to sign up for things, so I'm hoping you guys will. So sign up for anything. Anything that hits this server goes here, and it can be queried via an API, so you can download all the samples you want from it just via the API, super easy. If you set up your MX record to point to lacedmail.com, it will take the message. What was really fun was some spammer, I think, was looking for open relays, SMTP open relays, and they came across this, and they started to use it to send out their spam. But we're not sending email, we're just taking email. So we actually got their entire spam list. It was crazy. They saw all of their different emails that they sent out. It was wonderful. So I encourage you guys to use lacedmail.com, totally free. It's for us, to do this kind of stuff. All right, so we only have a couple minutes left, but there was a couple of other things about exploit kits that has been just sort of lingering in the back of my mind. Two really quick things, and I thought, why not? Let me tell you guys about them. So let's do it. So the first thing is this. I've spent a lot of time looking at the exploits that are delivered by exploit kits. Right? I care about this stuff a lot. They're heavily obfuscated, so anybody who's done this has appreciated this quite a bit. But I spent time de-obfuscating all of this JavaScript and looking at it, and actually reconstructing the entire exploits that they're using. Because I want to look at how they're, what does their ROP chain look like? What does, how are they arranging the heap when they're actually exploiting the browser? What are they doing? And so one really interesting thing that I found was this. This is the magic address. So if you know about exploitation, in some cases if you can do a heap spray or some sort of spray of data, there's a magic address that once you spray enough data, you can know that reliably whatever object that you're trying to place in memory, it will be at this address in memory somewhere. Right? So it's called the magic address. It's just people run it 100 times, and then whatever address always has it, they use it. So there are published magic addresses. Everybody people who write exploits know what these addresses are. There's articles, talks, they outline it. Usually everybody uses the same magic address. Well, the one thing that I noticed that was sort of weird was that there was one or two exploits that used this magic address. I've never seen this magic address used ever before in any exploit that I've ever seen. Maybe you have, but I have not. So I started to think this could be a really, this could be sort of an interesting way to track different actors, right? Because I can know pretty reliably that probably the person who wrote the first exploit is maybe the person who wrote the second one, or at least know each other, because this is a very unique value that no one else has picked. So one little piece of tidbit information. So if you ever decide to look into this, note the magic address and see if maybe you can tackle it. And the last piece is this piece. So after you do one of these big sprays and you overwrite, a lot of times what you're trying to do is overwrite an array object in memory. And when you overwrite the array object in memory, you search memory to find that array object. The way that you find it is that the array object's length field is different than what you set. So you overwrite the length field, and then you find it somewhere in memory. So once you find the array object, you sort of know it's, you sort of know that you found the right one because it's the only one with a different length field, right? For whatever reason, this author decided to include this additional check within their exploits where they actually decode the hex of decode into memory and then read it back to confirm that they're at the right array object. It's totally unnecessary, but for some reason these guys decided to do it. So another interesting tidbit to follow up. All right, so just to recap, wait, am I on the right side? See Homer? All right, good. So just as a quick final recap, I hope you guys enjoyed all of Matt's work. He is an intern and hopefully will work for us one day. You can, a couple of things. One, I would encourage you guys to roll your own scraper or proxy. It's totally doable. There's lots of good, easy ways to do it. Learn from our experiences, and hopefully you'll be able to do some good stuff. If you are finding bad exploit kit stuff, make sure you think about how to amplify that. How do you pivot off of a piece of information and use it to find more information? Because these exploit kits are really integrated. It's a network, right? There's a whole network that's associated with this thing. And if you find one piece, you can find a lot more. So make sure you think about that when you're dealing with your exploit kit stuff and doing your research. Bad guys make mistakes too. Maybe you could benefit off of that. That's all I'm saying. And the last thing is disposable mailboxes can actually be used for research, and they could be a good, nice, fun way to find new samples. All right, that's everything. If you have any questions, please go up to the mics.